So here we will find out the fringe width of bright and the fringe width of dark. It is very similar to the fringe width that we calculated in case of interference. If you remember, in case of interference, to find out the fringe width of bright fringe, we took two consecutive dark fringe and then subtracted their position. But here same thing we will do. For bright we will take two consecutive dark and we will subtract their position, but here position comes in terms of angle as well as linear. So that is why the fringe width will also be angular width and linear width. Angular width means in terms of theta. So since here we are finding for bright, we have to subtract the position of two consecutive dark. Now what was the formula for dark? For dark, okay, this was the general formula for dark. This one linear one and this one angular one. Okay, fine. Now what we did there, theta n plus 1 means it is the position, angular position of n plus 1th fringe minus theta n. So for theta n, as it is this equation, for theta n plus 1, in place of this n we will write n plus 1. That's what we did there. Okay, let's see. Yes, this one. Okay. Theta n plus 1 is the angular position of n plus 1th dark fringe. Theta n is the position of nth dark fringe, two consecutive. Then you substitute the value in place of n, here n plus 1 and here it is n only. So after subtraction we will get this one, lambda by a. So this lambda by a is the angular width. For linear width, directly you can do one thing. You just, as we know, from angular to linear to convert, we multiply it with capital D. So that one also you can do. Result will be this one, or you can do it in this way also by subtracting. Means yn plus 1 minus yn. This is linear width, and yn plus 1, this was the formula in place of n plus 1, and yn, this was the formula for dark. Okay, because we are finding bright, that's why two consecutive dark we have taken. Then subtract, you will get this one. Similarly for dark, if you find out, then angular width of two consecutive bright we will subtract. Though we will write it like this only, but this time the formula of bright we are going to use. What was that? This was the formula, twice n plus 1 lambda by 2a. Okay, but this is for theta n. But if it is theta n plus 1, in place of this n we are substituting n plus 1. Okay, that's what I have done here. In place of n plus 1, and this one will be n only. You can do the calculation and the result will be this one. Same, lambda by a, lambda by a. This is angular. For linear, this formula, you can substitute this value, or else with this also you can multiply it with capital D. That will give us the linear width. Okay, so this was all about diffraction. Now one more thing is there in this one, difference between diffraction and interference, and that is the end of this chapter. So the difference I will give you, not in video, but I'll give you one note. Okay, thank you. So that is the end of this chapter. Thanks.